In 12.3, you're going to need your notes from 12.2 to help you remember what the parent functions are, because we are going to use the parent functions to do some graphing and writing of translations and reflections of each parent function. So we're going to want to be able to do all of these things, and it's easiest if we have those notes with us from the parent functions. So if you want to pause the video and copy down these notes onto your notes, this is a list of all of the translations and reflections and how they will show up in an equation when you look here, and also when you're graphing how each of the values change, whether the x values are changing, the y values are changing. So go ahead and pause and write this down, and then we're going to use these in our examples. So on example 1, it says to reflect the cubic parent function. So if you look back at your notes, the cubic parent function, the original function is y equals, I'll write it down here, y equals x cubed. That's the parent cubic function. And we want to reflect that across the x-axis and then translate it 1 unit down. So reflect across the x-axis. So we come up to our notes up here, reflecting across the x-axis is this one. So if we are reflecting across this x-axis, then we know that our function is going to change from f of x into negative f of x. So whatever our function is, we're just going to stick a negative on the front of it. And all of the changes you're going to make are going to be to the right side of your equation. So this is going to become, and maybe I'll do it this way. This is going to become negative x squared. So you just stick a negative on the front, just like this table tells us to do. So this section right here is what we're going to be using to write our equations. So we reflected across the x-axis, check, we did that, and then translate 1 unit down. So if we go 1 unit down, this is down. So whatever we go down, we want to change from f of x into that function minus however many we're going down. So then we just take this function that we have, and we are minus, and we just put minus 1 because we're just going down 1 by the end. And when you have an original function and a future function, usually they're labeled in function notation. But if the first one is f of x, then after we do the transformations, it becomes a new function, so it needs a new name. So we'll just name this g of x. So just a different name because it's a different equation, different graph. And if you want to use your graphing calculator, you can graph the original and then graph the old one, or the new one, sorry. And then you can check to see if it did what we wanted. So the original graph looks like this. And so if we reflect across the x-axis and then 1 unit down, so reflecting across the x-axis looks like this kind of. And then if we translate it 1 unit down, it should shift down. So you just check to make sure it did what you wanted, and then that's that. So example 2, let's do the same thing. The square root parent function. So our original function is the square root parent, which is just the square root of x. We're going to reflect that across the y-axis, so that's this green one right here. And this says that we're supposed to take f of x and we're going to change it to f of negative x. So anytime you have something that's changing on the inside of x, what you need to do is in your equation, you go to wherever x is, and here is our x. Sometimes it's in the exponent, sometimes it's in the denominator. This time it's in the square root. So you go there, you put parentheses around your x, and that is the part that you change. You make all your changes inside that parentheses. And so this green said I'm just supposed to change it to a negative x. So in parentheses, I'll just have negative x. So I've done my reflection. And then we need to translate 4 units up. So let's go to our table, 4 units up. So that's the very top one, up 4 units. It means I'm just going to be adding 4 to the end of my function. So we just take our function, add 4 to the end, and there we go. We've done all of our transformations. This is a new function, so I'm going to rename it. And there's my final answer. Okay, go ahead and try these other ones. So example 3, go ahead and pause it, write down what you think it is, and then we can check our answer. The original is the absolute value parent function, so absolute value of x. And then our new one, 4 units left. So that's also, if you look at the table above, we're just changing the inside. So I'm going to put parentheses around that inside, and that's going to become x plus 4 if we're going to the left. And then we need to reflect across the x-axis, and that means if you look at the table above, we're just putting a negative on the very front of our function. And remember, all of the changes happen on the right side of the equal sign. I'm just renaming it on the left side. So there's our final answer for that one. Here is the next example. Go ahead and pause, write down what you think your answer is, and then we'll check. The original reciprocal is 1 over x. This time x is in the denominator, so that's where the changes are going to happen if I'm changing anything to do with x. So reflect across the y-axis. That means my x is going to be negative, so I put that in parentheses, and I make that a negative x on the bottom. And then translate 4 units right. This is tricky because this is also changing x. So what we need to do again is put x in parentheses. And this time we have to change the inside parentheses. So 4 units right, meaning I'm going to be minusing 4, so negative, and then the inside parentheses is going to become x minus 4. And there we go. There's our final answer, but it's a new function. So I guess this is not actually equal. But here's our final answer. Okay, describe the transformations necessary. So we're given an equation, and we're given an equation that's already been changed, and so we have to figure out what happened from the first to the second. So new stuff. We have x, used to be x, and it's in the exponent. Doesn't matter where it is, but x became x plus 2. So it only changed where the x, and we can kind of imagine that being in parentheses. It's only changing where the x is. So that is going to be a translation to the left 2. Because if you look at your chart above, the first and second columns, we're looking for, okay, where does it change just the x to x plus a number? And this is where we change x to x plus a number. So that's a translation left. Okay, next is, we also have this minus 3 at the end, and it's just at the end. So if you look at your table above, if we're minusing something at the very end of our equation, that means we're moving it down, translation down 3. All right, try that out with this guy over here. Pause the video, try it out, and then check your answers. Guess we'll go in order here. So the first one I notice is this negative, and it's just the x that's negative, not the whole function. So that means it's a reflection across the y-axis if it's just the x values that are changing. And then we have this plus 4 is new, and it's just sitting at the end, not on the inside with the x. So this is a translation up 4. Okay, now we're on to graphing. So we can use the right side of the table up here to help us figure out how our values are going to change. So I'm going to show you how to use the change of values in graphing, but you can also use your calculator for this to get some specific points. But in the graph, you have to have specific points on your graph. So you can plug this in your calculator and get specific points, but I want to show you how it works with the parent graphs. So my parent graph is the most basic of this, so it's the cubic function is the parent graph. And if you look at your notes from last time, the parent graph we had these points. So negative 2, 8, 1. Oh, these were negative. 0, 0, 1, 1, 2, 8. Okay. So what's happening here is we have a reflection across the x-axis. And if you look back at our chart up here, reflection across the x-axis means, if we look at the right column, means all my y values are going to change signs. So if we go down to this table, I don't want to graph those original points. I want to graph the new points. So all my y values are going to change signs. So that becomes positive. Positive 0 stays 0. That becomes negative. That becomes negative. And then the next thing that happens is we go down 3. And if we go down 3, if you check the table up above, that means all of my y values, we're going to minus 3. So if we just minus 3 from all of these, minus 3, minus 3, minus 3, then 8 minus 3 gives me 5, 1 minus 3, 0 minus 3, negative 1 minus 3, negative 8 minus 3. Okay, so now we have new y values. We have these y values, and we have, let me circle the new, so these are our new y values, but we still have these x values. Those x values have not changed. So now we can just graph those new points. So negative 2 comma 5, negative 1 comma negative 2, 0 comma negative 3, 1 comma negative 4, and then the other one doesn't fit on here anymore, but that's okay. So then I can just sketch that in from there. And there we go. So my original graph, again, if you remember the cubic function, looks like this. So reflect, it looks like it's reflected, yes, and down 3, which, yes, again, it looks like it worked how we wanted it to. So you can use that right side of the table to help you figure out how to graph your new function. Or again, you can pick up these same points by plugging this equation, this full equation into your calculator and just checking out the table from there. So yeah, so go ahead and pause the graph or pause the video and graph this and then check your answer. My original points for this, 0, 0, 1, 1, 4, 2, and 9, 3, which doesn't fit on here, but maybe it will after we move this. So this is left 2. So all my x values, I'm going to minus 2, minus 2, minus 2, minus 2, minus 2. So my new ones are negative 2, negative 1, 2, and 7. So those are my new x values. And then this is up 3. So I'm going to add 3 to all my y values. Plus 3, plus 3. So 3, 4, 5, 6. Okay, so I have some new points to graph. So negative 2 comma 3, negative 1 comma 4, 2 comma 5, 7 comma 6. So that actually does fit. 7 comma 6. And there we go. My original graph is the same thing. It just starts at the origin. So this one should have moved left 2 and up 3, and it looks like that happened. Okay, next one, we have a reflection. It's a cube root function. Cube root has been reflected and moved to the right 4. So pause the video, sketch a graph, go from there. Okay, check your graph. There we go. So on your graph, even if you don't write down the points in x and y coordinates, I want to see the points where you are graphing specific points. Okay, this guy, the only points I want to see where your asymptotes are going to be, and I want to see where like 2 of your points are going to be. The rest are just fractions, so I'm going to see those are the main pieces of this graph. So we have a reflection across the y-axis. These are where my normal, this is kind of where everything starts on my parent graph. So I'm going to take those and I'm going to reflect them across the y-axis, and then I'm going to move them up 3. So that means my asymptote is going to move here. This asymptote stays where it is. And then this point has moved to this side, and this point has moved to this side. And there we go. There's our new sketch of our new function with the asymptotes and these 2 points on specific marks. The last type of example we're going to do is we're given a new equation, and I'm actually going to change the instructions on this a little bit. I want you to write g of x in terms of f of x. So how did we take the original function and change it to become the new function? But I also want you to write an equation based on what the original parent graph is. So g of x, the first thing we're going to do is just follow the instructions it says right there. So g of x is going to equal f of x, but we have to do some changes to f of x. So this is my original, this solid line. And what are the transformations that happen? So First of all, I know that it flipped upside down, so there had to be a reflection in there somewhere. So reflect across the x-axis. I'm just writing this down to keep track of things in my brain. So if that's the case, then we took f of x and we, according to our table chart up at the top, we just put a negative on the front. We reflected across the x-axis. Okay, but that's not it. After I reflected it, it looks like it moved down 1. So down 1, if that's the case, then I need to take my f of x function and I need to minus 1 at the end. And there is my g of x in terms of f of x. But I also want you to identify this original function is the absolute value function, so absolute value of x. So you're going to have to, on a different type of question on your assignment and on the quiz, you will have to write the actual equation of f of x. So the original equation is absolute value of x. So I'm going to make the same changes I made here. So my new function is actually negative in front, but instead of f of x, I'm going to actually put absolute value of x and then the minus 1 at the end. And there is the actual equation of that graph. And you can type that in your calculator and just make sure you did it right. But there we go. Let's practice with that one more time. So solid line is my original, and the dashed line is the new. So g of x, what did I do to the original in order to get it to where it is right now? So it doesn't look like it was reflected or anything. It's the same orientation, but it moved 1, 2, 3 to the left. So I need 3 left and 1, 2 up. So f of 3 to the left means from my table I get x plus 3 on the inside, and then 2 up is just plus 2 on the outside. So there is g in terms of f, but then on a different question, if it asks you to identify the parent function and write the equation, my parent function, the original one, is looks like the x cubed function. So then my actual equation for g of x is going to be all of these same changes, but just on the x cubed. So remember, if anything's in parentheses, that goes with the x. So I'm going to put my x in parentheses, and then I'm going to rewrite this. I got to squeeze this in a little bit. So x plus 3 is going to be in the parentheses. The cube stays on the outside. And then I need that plus 2 on the end. And there is my equation of the new function.